Welcome to Combining Functions presented by www.free-academy.com. This is the third lecture in our calculus series. We're going to start off with two different functions, which are going to be f of x and g of x. And we're going to explore different ways of combining these functions. Now these first four here, I cannot think of a time when you will ever see this. But we're doing this to be thorough. Later in the lecture, we're going to see things that you will see a lot. You'll use all the time. Watch all this lecture because it's very important to have a very good understanding of all this, because if you don't get this, this is going to cause you a ton of problems throughout this entire course. If you have in parentheses f plus g of x, that is the same as saying f of x plus g of x. Since f of x equals x squared and g of x equals 6x, this gives us our new equation out. We have added f of x and g of x together. Now I said you guys will never see this in your life. You'll never see this part of it. The f plus g in parentheses. You will see the f of x plus g of x all the time, and that will be true for the entire column actually. So I guess I was a little hasty before. Pay attention to this column. The second column. For the same reason, f minus g of x equals f of x minus g of x. And you can see that that is x squared minus 6x. If you have fg of x, that's the same as f of x times g of x, which is x squared times 6x, which is 6x to the third. F divided by g of x equals f of x divided by g of x. X squared over 6x equals 16x. So that's very rudimentary stuff right there. You can add, subtract, multiply, and divide functions. Keep that last statement in mind. That's very important. Much more important is the combination of functions this way. We're going to keep the same one. F of x equals x squared and g of x equals 6x. You can have f of g of x. Another way of writing this would be in parentheses f circle g of x. It's the same thing. Using our placeholder strategy that I did before, your f of x equals x squared. G of x goes right into the parentheses. So the blue parentheses, actually let me use different colors. Let me color code this. The blue parentheses represent the parentheses produced by your g of x, and the green is your actual g of x. What this all equals is 6x squared, which is 36x squared. Not quite sure why I wrote like that. 36x squared. This is what's known as the composition of f and g. By the same logic, we can take the g of f of x. And we start out by writing our g of x using parentheses as placeholders, and then placing our f of x inside those parentheses. Keep in mind, it's just it's a matter of coincidence. Actually, never mind. Forget what I was just saying there. That was completely irrelevant. I'm going to keep going with this. F of x equals x squared. G of x equals 6x. Now let's say we wanted to find the f of g of 2. And again, I'm going to break things up using different colors here. We write out our f of x with the parentheses, with our placeholders, and we're going to put g of x using our placeholders. And then we're going to input the value of g of x into the placeholder. So we got 6 times 2 squared. That equals 12 squared, which equals 144. This is all I'm going to do on this for this lecture. I am going to do a lot of practice problems explaining this out because it's a very, very important concept to have. And I'll label those practice problems independently from what we're going to cover in the rest of this lecture here. So check those out if you need more help on it. Again, make sure you know that part very, very well. It's really important. Moving forward, gotta grab a different color here. We have even and odd functions. Alright guys, this is going to seem pretty archaic. You're not going to use it this much until you get to integrating much, much later. Then knowing even and odd functions is going to be pretty important. For something to be an even function, we're going to meet a couple of conditions. The graph of f of x is going to be symmetric about the y-axis. Notice that in our parabola here, one point on the positive x reflects around the y-axis. We have an axis of symmetry and the y-axis. That's an even function. To write this out mathematically, the equation y equals f of x must also equal the equation y equals f of negative x, which you can distill down to say if f of x equals f of negative x, then your function is even. Using the parabola for example, f of x equals x squared negative x squared. Notice that the square of negative x squared also equals x squared. So a parabola is an even function. Now we're going to move on to odd functions. And that's a really annoying color. I'm not going to be using that anymore. Yeah, that's much better. Alright. An odd function, I'm just going to skip the graph on it and go right into the mathematics function. You have f of x equals negative f of negative x. That is going to be our mathematical definition for an odd function. F of x equals negative f of x. Let's do the example f of x equals x. So x and then negative x. Remember, I'm still just using my notation of using the parentheses as a placeholder. The x is a placeholder. So we put negative x into where our x was, and we multiply it by negative. Notice a negative multiplied by a negative gives a positive x out. So x equals x. This is an odd function. And the book says here, if a graph is symmetric about the origin, then it is odd. If we were to put this on our graph here, for every point we add, we would have to have another point, and that would make our line of symmetry negative x, I suppose. So that is even, odd, and then combination of functions. We'll do lots of practice problems on this. Hope it was